Welcome back, students. In this video we are going to cover Module 10, Topic 4, Inscribed Angles. Let's see, I'm going to go over the standards this time just because kind of getting into a lot of different stuff. So we're going to cover GR 5.3, that is to construct the inscribed and circumscribed circles of a triangle. GR 6.2, solve mathematical and real-world problems involving the measures of arcs and related angles, and 6.3 is solve mathematical problems involving triangles and quadrilaterals inscribed in a circle. So as I was telling you guys, circles, first we'll talk about the circles themselves, and then we'll start talking about shapes inside the circle, and that's kind of where we're at here. Alright, so the objective for this topic, you guys are going to solve problems using inscribed angles. And we'll talk about what those are here in just a second. So the warm-up, here we've got several angles. They're in the circle, which that's what inscribed means. It's an angle inside the circle, but they're different types, and we'll talk about those here just below at the bottom. But yeah, so for the warm-up, answer true or false. So one thing I want to kind of point out before we get going, so notice this line is a straight line, and then the angles, so this would be 180 degrees, and this would be less than that, and they get smaller as you go to the left. So kind of like on the coordinate plane, as we go to the left, it's negative. Well, here left is smaller. So for number one, so they're asking if the measure of angle AOB, so that's right here, is greater than AEB. So see, AEB is far right. That angle is much smaller than AOB. So AOB is greater. Let me just swap to my red pen, excuse me. True. Okay. And here's what we'll do. We'll just do AOB, the brown, and AEB. Of course, this crazy. Yeah, I'm losing. There's no lead to that. So anyway, so yeah, so brown is greater than blue here. Alright, number two, AFB. So AFB is the straight line. Is it greater than ADB? Well, this straight line is 180 degrees, so it's way bigger than anything else here. So that is also true. Sorry, I keep trying to use the wrong pen. Let's just say we'll make the straight line pink, AFB. Let's see, what have I not used? Green. So ADB. To correct for that stupid lead on my bumpy table. Alright. Let me see. Hold on. Okay. Now, let's see. What's our next one? AOB. So AOB, is it greater than 180? So 180 is a straight line. This is less than a straight line, so that is false. Alright, so ADB, so up here that was the green one, is it greater than the pink one? Well, remember this is the biggest, then we get smaller from this point, so D is not bigger than F, so that's false. And then lastly, ACB, and that's the only one I didn't. I guess we'll just use yellow, that's all we got left. So ACB, and then AOB, which was the brown. So you see C is to the left of the brown, or to the left of O, I should say. So it is not greater than, so that is also false. Alright, so let's talk about inscribed angles. So inscribed angles, there are three ways that an angle can be inscribed in a circle. Case one, so center P is inscribed on the inscribed angle, so it's on it. Okay. Could be inside. Let's just say inside. Okay. And then it can also be in the exterior. So I guess I'll just do it this way. Okay. You guys know I'm not very good at drawing. Well, I'm not very good at coloring either. There we go. So either on the angle. Let's just do the blue is not working, so we'll just say bumpy table on the inscribed angle. So on the angle, inside the angle, or outside or the exterior of the angle. Okay, let's look down here, bottom of the page. So we're page 7 on the top module 10 packet, by the way. Alright, so theorem 10.7, inscribed angle theorem. If an angle is inscribed in a circle, then the measure of the angle equals 1/2 of the measure of the intercepted arc. 1/2 the measure of the intercepted arc. Alright, so for this, hang on, let's see how I'm going to draw this. We'll do yellow again. Okay, so for an example, so angle 1, that's the, mark it in red up here, it's 1/2, it equals 1/2 the measure of arc AB. And arc AB equals 2 times the measure of the angle. So the angle is half the arc is double the angle. So in this example, measure of angle 1 is 35. What's the measure of arc AB? Okay, so the measure of angle 1, let's see, well, yeah, so arc AB, as we say here, we'll just do this. So measure of AB, arc AB, is equal to 2 times the measure of angle 1. Alright, so if that measure of angle 1 is 35, so measure of arc AB is going to be 2 times 35. And 2 times 35 is 70. So, see, it's that easy. So, in this case, the angle, let's just write it in pencil here. So, the angle was 35 degrees. So, the arc was 70. So, this is double this, or this is half of that. Alright, flipping over page 8. Down here or up here, I should say, to the top of the page. So page 8, theorem 10.8. If 2 inscribed angles in a circle intercept, hold on, let me, sorry. Technical difficulties, folks. Alright, I had to get my pen here. Okay, so 2 inscribed angles in a circle intercept the same arc or congruent arcs, then the angles are congruent. Let me try to figure out how. So in this case, B and C both intercept arc AD. So this angle and this angle intercept this. Let's see. Let's say here. And it comes from, just go ahead and highlight it. It comes from here. So this intercepts that. And this intercepts that. And they show, and it's little tiny, but these two are congruent. and of course that's what we put here. So angle B is congruent to angle C. So right there. Alright, moving down the page here. So we'll keep these notes close. Alright, so number 1. So I'm going to do number 1 and number 3. And number 5, give you the notes. You guys are going to do 2, 4, and 6. Alright, so number 1. Given the measure of angle D is 40 degrees. So 40 degrees for D here. And the measure of arc DE is 98. And wants to find CF. Okay, and you're like, well, how the heck are we going to do that? Well, hold on, I'll show you. Alright, so we'll just say DE's pink. And it's 98, and let's see, angle D is 40. You see that angle D makes CF here. That's going to be important. Okay, so we want to find CF. So 98, 40, CF. So remember, the angle is is half of the arc. The arc is double the angle. So in this case, keep putting that red pen down. So the measure of arc CF is going to be equal to 2 times the measure of angle D. Okay, because this is half of what this is, and so that's why we're multiplying it by 2, because it's half of that. Alright, so 2 times what was D? D was 40. 2 times 40 is 80, so the measure of of arc CF is 80. So it's another one of those football plays where we went in motion over here and we ran the ball to the left. Well, they showed us this and that was fine, but we didn't need that. We only were messing with here. So keep that in mind when you're working the U-view over here. Alright, number 3. They give us that the measure of angle D is 40. This time we'll do it like this. So it looks similar to the one above. Let's see. But now we got a different situation going here. So let's see. DE is 98. Find angle C. So this is like the Fantastic Four here. But so angle C. I'm going to draw to the outside of D here because this is one side of C. That's the other side. So you see that angle C is made up of arc DE. Or it creates that arc. So the measure of angle C is going to be 1/2 the measure of arc DE. So remember, up here the arc is double the angle. Down here the angle is going to be half the arc. So it's going to be 1/2 of 98. And half of 98 is 49 degrees. So the measure of angle C is 49 degrees. Hopefully that makes sense to you. Alright, skipping down the page, number 5. Just going to go ahead and write this in real quick. The inscribed polygon down here for when we get to those notes. But number 5, so they want to find the measure of angle A. So angle A goes to point B. It goes to bumpy table. Bump. So it goes to BC. Alright, they want to find the measure of angle A. That's that. Oh, so they give us X here, so yeah. Let me see. Okay, oh yeah, I see what they did here. So notice these two go to that, and notice angle, we'll do it this way, I should have, so angle D, got to look at what they give you to figure out what they're asking. So notice both of these angles make the same arc, and if they make the same arc, they're going to be congruent angles. So to find the measure of angle A, we're going to put these two equal to one another and solve for x and then plug it in. So what's going to be is angle A is going to be congruent to angle D. So that being the case, angle A is also, the measure of angle A is also equal to the measure of angle D. The measure of angle A is 5x minus 12 degrees, and then D is 3x plus 2. Alright, so the 3 is smaller, so I'm going to start by subtracting 3x from both sides. That cancel. 5x minus 3x is 2x. Just said 3 and I wrote it. Minus 12 equals the 2. Add 12 to both sides. So we got 2x is equal to 14. Divide both sides by 2. X equals 7. Alright, well they wanted angle A. So angle A was 5x minus 12, which is 5 times 7, that was our x, minus 12. So 5 times 7 is 35, 35, minus 12, so the measure of angle A, 35 minus 12 is 23 degrees. Okay? Alright, now I'll leave you with 2, 4, and 6. So, right here's. Alright, so let's scooch to the bottom so we can finish off this page. Alright, so in an inscribed polygon, so that's what we're going to talk about now, all of the vertices of a polygon lie in a circle. So, and inscribed triangles and quadrilaterals have special properties. So theorem 10.9. So an inscribed angle of a triangle intercepts a diameter or a semicircle if and only if the angle is a right angle. So right here at the bottom, so all three, let's see, it says angle G is the 90 degree. I thought so. See, this is the hypotenuse. Down here, that's the diameter. So if FGH, so if FGH is a semicircle, then measure of angle G is 90, and if the measure of angle G is 90, then FH is a semicircle, and FH is the diameter, which is all true. See, it makes the half a circle. Okay, simple enough. Flip over. That's page 9. Page 10 is the end of this topic, but that is extra practice. We will stop on page 9. We're going to talk about theorem 10.10, and then we're going to flip over. We're going to flip over. I'm sorry, not flip over. We're going to scooch down to do the 2 I do's at the bottom. I'll leave the 2 you do's and the extra practice for you guys. So yeah, let me just. 1 second. Okay, so theorem 10.10. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So just like when we talked about quadrilaterals before, the opposite angles are well, actually, if it's inscribed in a circle, opposite angles are supplementary. We learned outside the circle they're congruent. So example here, so if quadrilateral KLMN inscribed in circle A, then angle L and N are supplementary, and K and M are supplementary, so I made them yellow and pink. Alright, next, the circumscribed circle of a polygon. So we talked about the shape inside. Well, now we're talking about the circle on the outside. Alright, so that circle is a circle that contains all the vertices of a polygon. The circumcenter of a triangle is the center of the circumscribed circle. So, well, you'll see. Yeah. All right, so number one, we're going to find the measure of angle CBD and the measure of arc CD. All right, so angle CBD and arc CD. Is that what they want? I'll make sure. Okay, yeah, so they want this angle, and this arc. Okay. So, all right. So CBD. Let's see. 180 minus angle. Hang on a minute. Oh, okay. All right. That's what I was confused. I was looking at angle measure and the arc. So we'll do the angle first. So the angle here. So remember that these angles right here would be, these two would be supplementary and these two would be supplementary. So to get angle CBD, it's going to be 180 minus this guy, because if these two equal 180, it's just 180 minus measure of angle E. So it's 180 minus lumpy table. Man, that's getting worse and worse. Measure of angle E is 63.5. We subtract those, and the measure of angle CBD equals 116.5 degrees. Okay. Let's lift this up because I'm trying to brighten on the bumpy thing. Okay, sorry about that. Okay, now. Alright, so now we want to find arc CD. So the measure of arc CD is going to be, hold on, I have to put my notes under here. Yeah, that's right. So this arc is going to be twice that angle, so it's 2 times the measure of angle E. So that's 2 times, E was 63.5. 2 times 63.5 is 127. So the measure of arc CD is, oops, is 127. Oh, sorry, I didn't realize I was so far off the page. I mean, off the screen like that. Give me just a second. Let me pull this page out. Okay, so go down here to the bottom, number 9. This is the bottom of page 9. This will finish off the topic. Like I said, next page is extra practice, so please be sure to do that. So, number 9, measure of angle K is what they want. So they want this angle, which is this equation. So as usual, we're going to solve for x, and then we're going to plug it in here. Alright, so we know that a triangle equals 180. We know this is across from there, and we learned earlier that if this is the diameter, and it is, then this is a 90-degree angle. So to solve for x, we're going to put all 3 of these angles equal to 180. I'm just going to put angle M plus angle L plus angle K. Alright, so we got M is 8x minus 10 plus L is 90 plus K is 5x minus 4. Now I did this on purpose, so we're going to add these two together. So 8x plus 5x is 13x. We have a negative 10 and a negative 4, which makes negative 14. And then the 90, so 90 minus 14 is 76. So we cleaned up all that. That's all equal to 180. Okay, subtract the 76 from both sides. These cancel. 13x is right here. This is 104. Make sure I'm still on the right path. Yes. Alright, so divide both sides by 13. X equals 8. Alright, we want to plug it in there. So, measure of angle K equals 5x minus 4, which is 5. X is 8 minus 4, which is 40 minus 4. So the measure of angle K is 40 minus 4, which is 36. And it's an angle, so it's degrees. Alright, well, that's it for this. Got any questions, let me know in class. Till next time, have a good night.